Hello, everyone. My name is Andres Abeyta. I'm the Executive Director of Bootcamp GIS, education platform for subject matter experts to teach the rest of us. And one of these subject matter experts is David Foster, who's the co-chair of the SAME Geospatial Working Group. Great to have you again, David.
Andres, again, thank you so much for having me. Such an incredible opportunity to geo-evangelize.
I'll evangelize it to as many people as I can. Your
Amen.
words. So thanks for joining us again. Today's topic is to really give a sense to the audience of all those different areas that geospatial engineers really impact with the work that they do. And if you step back out or just have this 10,000-foot view, sometimes we don't realize, we make a map and what are the impacts of that? What decisions are made? What lives are saved? What time is saved? What millions of dollars are saved? And I think you have a really good perspective from that higher echelon of people that think in those terms. So I'll just jump in with the first question is, how do you see GIS making big picture decisions in infrastructure?
Well, great question. What decision isn't made with location taken into account for infrastructure investments? It's so critical and so important, yet, I guess it's ubiquitous, so it's almost like forgotten that location's involved. But in the end, it's about what and when to build, how to build, and how to maintain the infrastructure and for how long once it is built. I mean, those are the three, packages or silos you could put how location intelligence, geospatial information and services support those things. And let's break it down. What and when to build. You've got master planning. So what do you use? Computer-aided drafting and design, geographic information systems. For the how to build, military construction, building information models, making sure that things fit together so that, in a 3D digital environment so that you don't waste money and resources figuring out that stuff doesn't fit together once you got all the stuff built. Computer-aided drafting and design, floor plans, etc. And geographic information systems, bringing it all together. How to maintain and sustain it. You got geographic information systems, you've got sustainment management systems, which are really the business side. You're doing environmental management and then the divestment part of base realignment and closure. Like, okay, we're done with this base. We're turning over to the Philadelphia Naval Yard, to the city of Philadelphia, for to let them, use it for their purposes, right? So we don't have to keep the overhead of maintaining this aging infrastructure. So across all of those categories is how investments are influenced by the knowledge provided by geospatial information and services.
Yeah, the hot new rage, I think, that I see in a lot of the conferences, presentations about digital twins. Do you have conversations about the requirements to have a set of data that really represents digitally likeness of every Air Force base?
DISD, which is at the Office of the Assistant Secretary of Defense for Sustainment, which provides guidance over all the services for this. GeoReadiness in the Navy, GeoFidelis in the Marine Corps, and Army IGINS in the Army. So that was a little bit of background, a long way of getting to. We've been doing digital twins for a long time, but we just didn't call it digital twin. And it's been like 2D. There's been some 3D, high definition survey, use of imagery and LiDAR, doing 3D feature extraction, using building information and modeling. That's certainly 3D or digital twin. The challenge has been really, it's hard. And it takes a lot of resources, right? And it takes a lot of people with really what we call low density skills. How many people do you know that are subject matter experts in BIM? Man, that's tough to find. Computer aided drafting and design, geographic information systems, surveying, right? But in our world as geospatial professionals, those are all the same career field, right? And those who have more than one skill set really have a lot more to offer than the other guys. But no, we've been doing digital twin for a long time. The current initiatives, there's a bunch of innovation initiatives across the services, well-intentioned. They're going to bring out some great examples and of how to go about doing things. I see the real challenge, though, as being resourcing individuals, computers, networks, storage, all of those things, the back end, to make digital twins, I'll say, a reality. I mean, we've been working on it, but to have a digital twin of every facility, that's going to take a lot of resources.
Well, lots of resources, lots of skill sets. Anybody on this call, just the idea of creating a digital twin with knowing, building information modeling and CAD and GIS and, pictures from the sky with LiDAR, lots of opportunity for you to get skilled and have real value to the marketplace, whether you're a contractor internal to a military unit, to have lots of work to do.
And again, it is in high demand. I mean, it is definitely, it's not going away. I think there was an article, I don't have it in front of me, but it was, what's the price for ignoring digital twin? Or something like that. Like, you can't ignore it. It's here. So face up to it, get engaged, and because it provides so much. We talk about geospatial engineering as, one of the responsibilities is that we describe the operating environment. That's like the holy grail, right? 3D with able to touch something, and then it gets all the data that's relevant, right, to that thing that you're touching. You couldn't describe the operating environment any more clearly than with a digital twin.
So let's go to a different area. What about military mission planning? Where is geospatial used in some big picture decisions that are probably beyond me editing point signs and polygons or showing someone where to collect a point with a GPS unit? What are the big decisions that people make?
Wow. Again, what decision isn't made without some form of location being taken into account? They call it joint intelligence preparation of the operating environment. The intelligence community, as well as engineers, describe the operating environment, but let's go with the built natural infrastructure as it relates to this conversation, and stay away from the intelligence community for the most part, although we are definitely mission partners. There are 6 phases of military operations, and it's actually a diagram in Joint Pub 3-34 that lays it out in a interesting, simple graphic to understand. And geospatial engineering is a part of every phase. And as a part of that, they support planning, modeling and simulations, looking at regional and international operating environments, supporting the strategic planning. Where is something happening? Where do we need to be postured? What's the human geography situation there, right? You're looking at politics, you're looking at religion, you're looking at tribes, you're looking at ethnic groups, you're looking at all these different factors that change the operating environment. So you're looking at human geography, you're looking at existing civilian infrastructure. I mean, if we're going to deploy to, Ghana, right? What do the roads look like there? Do they have roads that can handle, military load classifications of 70, 80, 90 or 100, you got big trucks with tanks on top of them and you're hauling them. Are we going to be tearing up the roads as we go through there? Well, are there bridge heights, right? Are we going to crush their bridges if we're on them? Are they wide enough to handle us? Are we going to run into them if we have heavy equipment trailers with tanks on the back? Are we going to crush them as we go underneath them? Railways, can their rail support movement of heavy equipment? Airports, seaports, distribution lines, hospitals, petroleum facilities, power distribution. Is there power? Or do we need to bring our own? I mean, we'll always bring a little bit of our own, but is there a national infrastructure? When I was in Liberia, serving with the UN, there was no centralized water, sewer, or power. If you had that, you had it local. I mean, it was right at your place. You had a generator that required fuel, and you had septic, which is hauled away, and water was brought in, right? So we're looking at those types of things, right? What's the capacity of the existing infrastructure?
Yeah, we grew up in the United States and we know, oh, great infrastructure, and we document it really well with GIS, but you go to some other country and either the infrastructure is not there, or you're going to have to collect all that documentation yourself.
Exactly. You're going to have to collect it, and so that you can maintain that awareness for the length of time that you're there. And, we always try to leave places better than when we got there. And so we will try to help build upon that, whatever the specifics are of the national objectives, of course. But, if we're at a forward operating location, we're looking at their capacities too, to be able to sustain the forces and project the force as desired. And so I'll speak to that real quick, if you don't mind.
Yeah.
So we're looking at forward operating locations, right? Which, there's multiple airfields around the world. I forget how many there are, but there's a cool database available. You can see the 22,000 or something more. Can you believe that? 22,000 or something crazy odd airfields, right? Well, which one of those can handle a C-17 or an F-16 or F-35 or C-5? What about Blackhawks, Chinooks, all these different types of aircraft? What's the length and width of the runway? Condition of the pavements, and we're breaking it down into individual sections, right? Not just a pavement isn't one big continuous pour of concrete. They're broken down into hundreds of sections, right? And each one of those sections has to be analyzed, surveyed, inspected, right? Well, where does all that data go? That's where GIS comes in, just as a hint.
Hey, so another area I've heard you mention this is force protection, and maybe you could try to describe where GIS might have been used, especially in a case we're all recently familiar with exit of Kabul. What do you think? What kind of applications of geographic information systems is there?
Wow. Whew. There's three primary areas, but you brought up, Afghanistan. Climate, weather, terrain, human factors, right? Enemy or organizations who aren't so friendly. All those things come together. Now you're starting to get some of that into the intelligence realm, which the geospatial intelligence community would work with. But it's a partnership between the geospatial intelligence community and the engineers. While they're looking at human factors, human intelligence, and all the other tradecraft areas, engineers really do provide that terrain expertise. So that's one part of it. So the engineers are helping, how about fence lines and mobility or counter mobility, right? How are you restricting traffic flow? Where are your traffic control points? Are they far enough away? Where are your barriers? Are your barriers high enough, thick enough for the types of threats that you're facing? And that's actually, there's a bunch of people involved in that, but ultimately it needs to be mapped and analyzed, right? Line of sight analysis, right? And that also ties together with the law enforcement and security side. when you're talking about the exit from Afghanistan. So looking at, surrounding areas, looking at built natural infrastructure and how to best manage it, control it, to reduce the potential threats to forces. Key products, right? What are the things that we as a community provide? And I'll just run down a quick list. We've got data standards, we've got geodatabases, we do precision survey, we build digital terrain products and put them on web-based applications and dashboards. We do bed down planning and analysis for the things that we talked about the expeditionary stuff. We conduct mobility assessments, bridges, roads, rail. Is my track going to sink in the mud because it's raining all the time there? And then command and control, which goes back to also the Afghanistan piece. That is just some of the stuff that we bring to the table. And if, like Andres said, if you're doing any of that, there's a place for you. And definitely recommend contacting Andres and Bootcamp GIS.
I'm glad you mentioned that, because often we learn a piece of software, but the end product that someone looks at to make the decision usually is a map, a dashboard, a table of statistics, and some sort of plan to say, if we do this, then this is an outcome. And if we do something else, plan B, we likely have this other outcome, so you can make decisions. So all of that stuff, really good. And the types of things that we think would come out of courses that many of you might provide on our platform. Well, that's some great insights in 3 key high decision-making areas. I want to express to the audience that we're looking for smart people who are working in those areas. And you might be in the military or exited the military and have some ideas on some really good workflows that others could benefit from. And if that's the case, you should contact me, because we welcome subject matter experts to share their workflows, earn some income from that, but we really expose that to the world. So all those ideas that you expressed to us, David, really cool, and we hope to just keep really sharing this type of information with American military engineers and others. So I appreciate your insights today. So thanks for your time today, David. It was a pleasure as always, and we'll see you on the next webinar.
Oh, thank you again, Andres. Appreciate it.
All right.